This is Dr. Carroll. Today's video is about standard template library iterators. So make sure you watch the standard template library before this video. So as a review, in the STL, there's containers which hold another object, and there's algorithms that work on those objects. But today's video is about the iterators, and that's how we cycle through the contents of a container. What iterators do is they provide a uniform way to go over the elements from most of the containers. And once you learn how to use iterators, to switch between the containers is almost trivial. It's amazing. You're going to love this, okay? And maybe you'll like even more is that it's a generalization of pointers, okay? And so that might be even more enticing. There's a couple different categories of iterators. The most common ones are forward iterators, which can proceed in a forward fashion only. There's bidirectional, which means you can go forward and backward through the container for each element. And then there's ones that are random access. You can get at any element in that container at any point in time. There's also input and output iterators, and they're mostly used in algorithms. So let's talk about syntax for iterators. So you'll have the type of the container, and then you'll do the scope resolution operator, and you'll have the term iterator, and then you'll give the iterator a name. Let's see some examples. We have a list of ints here, and so that's our type, and then we have the scope resolution operator, and then we use the term iterator, and that lets us get at that specific iterator that works for a list of ints. And here we've named it iter, which is probably the most common variable name for that. Let's see another example. We have a deck of persons here, and that's our type, scope resolution operator, iterator, and then probably the second most common variable name is ITR for iter. Now that we know how to declare one for an STL iterator, let's look at the operators that are used. There's several, but these are the most common. You could have an increment, a postfix or prefix increment operator, and it's going to advance the iterator to point to the next item. Now, by that, it kind of depends on the container what the next item is. You also have a dereference to provide access to the element that the iterator is pointing to, and we'll see an example of that in just a minute. You can also have the decrement operator, prefix or postfix, and that's going to point to the previous item. Now, you can't use that with forward iterators. That only works for bidirectional and random access iterators, obviously. You could compare two iterators for equality to see if, most commonly, if you've traversed through the whole list, you could check them for inequality with the not equals to. There's also methods in each of the containers to be able to get an iterator to the first element, and that's the method begin. Okay. There's also the method end, and a thing to keep in mind here is that it's after the last element, and so that's a common mistake when learning iterators is it doesn't point to the last iterator, it points past the last iterator. Sorry, the last element. It points past the last element. So keep that in mind as you're using iterators. The end points past the last iterator. Let's look at an example to help solidify this. So if we had a list of type ints, and we called it people. Not that people are numbers or anything, but just for my example here. Then we need to declare an iterator. And we'd do that by using the same type as the container that we want to iterate over. And then scope resolution operator iterator, and then we give it a name, iter. And then we're going to do, this is a for loop example. We'll do a while loop in just a minute. So with the for loop, we have to do the initialization. And so what we're going to do is we're going to leverage the begin statement here, and we're going to assign the iter variable here using the begin method for the people object. And it'll look like this. We're getting an iterator to the first element and assigning it to iter. Now for our conditional statement, we want to go until the iterator is not pointing past the end of the list. So keep going until we're past the end of the list. Well, it does not equal to this end one. And then so that we don't have an infinite loop, we need to increment the iterator. And now inside the loop, we need to use the iterator. And the way we do it is we dereference it. You can think of it as a generalization of pointers. We're going to dereference the iterator. Here the parentheses aren't needed, but in other cases they are. So that it'll print out each one of the numbers in that array. In that list. Now let's see a vector example. Here we have a vector. We're initializing the random number generator, and we're just going to choose 10 random numbers and put them on in turn, each on the end of the vector. And then we're going to go through the vector, and using the at method, we're going to print them out. Let's just see how that works. We have here 10 random numbers in the array. Great. So, but now if we wanted to use a vector int iterator, we would specify the type, and then we would specify iterator. You notice it comes up. There's also other choices here for iterators. And let's call it iter because that's what I'm used to. Now, here for, I said we're going to do a while loop. Okay, so we already know we're going to do a while loop. And we need to initialize our iterator with begin, just as we saw with the for loop. And we're going to keep going until iter does not equal, it's not the same as the last iteration one. And then to see out, we need to dereference the iterator. We can do that like so. Let's see, now let's get rid of that for loop. Well, okay, let's put in a increment here so we get rid of the an infinite loop. Here we go through, and it's the same as the for loop. The numbers are the same. So to end today's video, we're going to talk about two rules for general and efficient use in functions with iterators. One, instead of passing the containers that we're storing, pass iterators instead, and then operate on the iterators. And then two, instead of returning the container, return the iterator. What this allows you to do is, one, you don't have the overhead of maybe making a copy of the container, and two, it makes it generic. Once you've written an iterator, a method that takes iterators and return iterators, then you can apply it to any of the STL containers, making for great code use. That's it for today.